Hi, in this video I'm going to discuss mathematics, Edexcel IAL M3, Mechaanicss M3, January 2022 paper. Okay, so this is the first question in January 2022 Mechaanicss M3 paper. This is related to center of mass. This area is shaded, it's named capital R. A uniform lamina is in the shape of region R. The region R is bounded by the curve with equation y equal x into within bracket x plus a, where a is a positive constant. Positive x-axis and the line with the equation x equal a as shown shaded in figure. So that lamina is made by considering the curve and the line which is x equal a line. Find the y coordinate of the center of mass of the lamina. So normally questions they ask about rotating the lamina or rotating the given shape through 2 pi radians, but here it's actually not rotated, means it's a two-dimensional figure, it's a two-dimensional shape. So we need to consider in terms of area, but whatever it is, when we are finding the center of mass, we are going to use the general equation for the center of mass. We normally say x bar is equal to sigma mi xi over sigma mi. That's a general equation. We can find the center of mass from different reference points or different axes. For example, if you are, so far the questions were about find the x coordinate of the center of mass. That's the way the questions what I discussed the post papers appeared. They are from the origin we took it, but here it's about y-axis. We can find the center of mass in different from different points or different axes. For example, if you think about xy Cartesian coordinate, if there are different masses m1, m2, like that, there are many particles are there, mn, right? So if you want to find the center of mass of this system of particles, there could be entry something like this. If you want to find the center of mass of these particles from the origin, then we should be able to find their distances from the origin. Each and every particle's distance we should find from the origin. For example, there I can say the distance of this particle m1 from the origin, it could be taken as r1, because if I use x1 you might get confused, you might think it's around the x-axis. So r1 I take it. This is at a distance r2. This is at a distance r3. This is at a distance rn. Then the center of mass r bar, general format I'll write it in terms of origin, from the origin. R bar is equal to sigma mi ri over sigma mi. From this I can find the center of mass from the origin. Okay. Now if I want to find the center of mass of this system of particles, so you know the meaning, sigma mi indicates the total mass of the particles or total mass of the system of objects in the given system. Sigma mi ri means mi is the mass of a particle and its distance of its center of mass from the origin, or it could be a mass of an object and its the center of mass of that object from the origin. Like that, there are many objects, or maybe there could be many different particles. So we are finding the center of mass of the system of particles or system of objects. Okay, so in case if they ask to find the center of mass from the y-axis, that means if they ask to find the center of mass of the x coordinate of the center of mass. X coordinate of the center of mass means from the y-axis. If we want to find that one, we can imagine like this. Okay, so there are different particles m1 at a distance x1 from the y-axis, that is the x coordinate of the center of mass of particle m1 is x1. There could be some other particle that is at m2, the mass of the particle is m2, that is at a distance x2 from the y-axis, that is x coordinate of the center of mass of the particle m2 is x2. So there could be something m3, its x coordinate of center of mass is x3. Like that, there are system of particles. Now there could be nth particle, its center of mass from the y coordinate, or the x coordinate of the center of mass of that particle is xn. Okay, now the center of mass of the system of these particles from the y-axis, or I can say x coordinate of the center of mass of system of particles. X coordinate of the center of mass of system of particles is given by x bar equal sigma mi xi over sigma mi. Right. Same way, I can find the center of mass of the system of particles from the x-axis. That is, I can find the y-coordinate of the center of mass of the system of particles. So for that, I can draw the diagram again like this, or I can use the same diagram, but I'll draw it again. This is x, this is y. There's a particle m1. Its y-coordinate from x-axis is y1. That is y1. So there is another particle m2 somewhere here. Its y-coordinate from the x-axis is y2. There is another particle m3 somewhere here. Its y-coordinate is y3. And there is nth particle mn. Its y-coordinate of center of mass is yn. Okay, so if I want to find the y-coordinate of the system of y-coordinate of the center of mass of this system of particles, all are measured from the x-axis. So y bar is equal to sigma mi yi over sigma mi. So sigma mi means total mass. Mi yi means m1 into y1, m2 into y1. Like that, we have to add all those things. Summation divided by sigma. Okay, so I'm going to use this idea here. So in the given shape, the lamina, I need to find the smallest uniform scale, smallest scale or smallest shape that could fill. I already told several times, smallest shape that could fill the whole area here, not volume, area. So normally we consider a strip, a small rectangular strip, something like this. I imagine a small thin rectangular strip like this. Its distance is from origin at distance x. Its center of mass, because rectangular shape is a uniform strip, rectangular strip. So it's this point is the y, because this is the height of it is y. This is the height of the strip is y. This is the height. So this height is y. So the center of mass of this strip from the x-axis, or the y-coordinate of the center of mass of this strip, is at the center of this height, that is at somewhere here, that will be y by 2. So the center of mass, because the uniform strip is a uniform rectangular strip, so the center of mass will be at the half of the height, is a uniform shape. So it will be at y by 2. It will be at y by 2. Okay, so the width of this strip is dx. It's at a distance x from O, so the width is dx. Right, so we can consider the mass per unit area, because here is something related to two-dimensional shape. So mass per unit area, I can say rho. Then the area of this strip, the small area of this strip, delta A, is equal to, you know, width into height. Width is delta x, height is y by y. So y dx is the area of this small strip. So the mass of this strip, I can call delta m or mi. That is ith strip. I can fill the whole area by several strips like this. So mi is equal to its area into density. So that is delta A times rho. Rho stands for mass per unit area. This is a two-dimensional diagram. So that will be y dx into rho. Okay, so I need to find the so the center of mass of this particular strip that I consider is at a distance y by 2. So I can fill the whole shape, the shaded lamina, by filling the lamina by several strips like this. So I need to find finally the center of mass of this lamina. For that I am going to use this equation. So then I am going to use a y bar because the question is about y coordinate of the center of mass. So y bar is equal to sigma mi yi over sigma mi. That's the thing I am going to do now. Okay, so y bar is given by the center, the y coordinate of the center of mass is given by y bar is equal to sigma mi yi over sigma mi. Okay, so here we need to find the sigma mi, that is the total mass of the lamina. Okay, for that we need to find the total area. We haven't found it. Normally they ask first part, find the, if it is rotated through a particular angle, you can see those type of questions. First part they ask to find the total volume, is it? But here, first we need to find the total area. That's also included in this question, 7 mark question. So we need to find the total area first. We'll find that part. So total area into rho. Rho is the mass per unit area. I took it like that. Then I'll get the total mass of the lamina. Sorry, total area of the lamina. Total area of the lamina is equal to sigma mi. That is total area into the density. Density means mass per unit area. So we'll find that one first. For that we need to find the area first. So A, we know that A is equal to delta A is equal to y dx. So we know the y equation is given y equal x into x plus a. So that is x into x plus a dx. So the total area A is equal to integral of x into x plus a dx from 0 to a. The total area I need to find the strips from, I can fill the lamina by small strips from 0 to a. Okay, we'll solve this one. So it's going to be 0 to a x squared plus ax dx. So it's going to be x cube by 3, the limits 0 to a, plus ax squared by 2 0 to a. So it's going to be a cube by 3 minus 0 plus a squared by 2 into a cube by 2. Okay, so finally it will be the surface area is going to be, take LCM 6, so it's going to be 5a cube over 6. So sigma mi, the total mass of the lamina is equal to total area of the lamina into mass per unit area. Total area, we found it, 5a cube over 6 rho. That's the total mass of the lamina. Okay, so I found the denominator of the expression that I am going to solve it. Now I need to find the sigma mi yi. Okay, for that. Okay, so I can take this as equation 1 because I found the denominator. I am going to find the numerator separately. It's easy, I feel. So keep it as it is, equation 1, something like that. Yeah. Now sigma, I need to find sigma mi yi. So I am going to find sigma mi yi. So I is equal to 1 to n, something like that. So that is sigma mi yi means sigma y mi. So mi means y dx rho, y dx rho, that is mi, into yi is y. So the yi means the distance of the center of mass of this strip, that is from the x coordinate or y coordinate of the center of mass, that is y by 2. See, y by 2. Yi is y by 2. So into y by 2. Okay, so it's going to be sigma. I can take the rho out, anyway that rho will get cancelled with this rho. Rho by 2 I can take it out, so rho by 2 if I take it out into sigma y squared dx. Okay, so there's a variable y squared could be replaced by the given equations. The given equation is y equal x into a plus x. So y squared is going to be y squared equal to x squared into a plus x all in square. So we have to expand this one. So y squared dx. So it's going to be rho by 2 sigma y squared means x squared into a plus x all the squared, x squared into a plus x all the squared dx. We'll continue that rho by 2 sigma a squared plus, I'll write that way, x squared into x squared plus 2ax plus a squared dx. Okay, then it's simple. You just expand that one. It will become, there's a sigma with variation means it's going to be integration. So rho by 2 integral 0 to a, that's a limit, x to the power 4 plus 2ax cube plus a squared x squared dx. Okay, when we solve, we will get the value of the numerator. Okay, I'll erase it. I'll continue this here, that we are finding sigma mi yi. So I'll continue sigma mi yi, we are finding that is equal to rho by 2 into integrated x to the power 5 over 5 plus 2a x to the power 4 over 4, 2a times x to the power 4 over 4, a squared x cubed by 3, the limits from 0 to a. Okay, so now we need to substitute the limits. Anyway, when we put 0, all of them will become 0 because all consist x, so I don't need to worry about the 0 value. So I'll continue there, then it will become rho by 2. Substitute a, then it will be a to the power 5 over 5 plus a 2a here 4, so that will get cancelled, it will become 2 here, the denominator. So a to the power 4 into a to the power 5 by 2 plus this is a cube into a squared, a5, a to the power 5 over 3. 0 will be always minus 0, 0, 0. I don't need to put that. Yeah. Solve this one further. Rho by 2. For this, we can take LCM 30. So it's going to be 6a to the power 5 plus 15a to the power 5 plus 10a to the power 5. So that will be rho by 2. 31, 10 to 25 times 31 a to the power 5 over 30. That is 60. So I can say 60 now. 2 into the 60. So I'll write it like this. 31 a to the power 5 is equal to 31 a to the power 5 over into rho over 60. Okay, this is the second one. Okay, so we know that sigma mi xi over sigma mi x mi yi, we found it. Sigma mi, we found it here, that is this one. So the y coordinate y bar is equal to sigma mi yi over sigma mi. Sigma mi yi, that is 31 a to the power 5 rho over 60 divided by sigma mi 5a cube rho over 6. Okay, solve it. So here you can see that 31 a to the power 5 a cube, so it will become a square. Rho will get cancelled, so this 6 will go up, 60 will come down, so 60 divided by 60, 10 into 5, 50, is it? So finally the center of mass, y coordinate of the center of mass will be 31 a squared over 50. Question Question number 2, this diagram is given. A particle P of mass m is attached to one end of a light inextensible string of length 12. The other end of the string is attached to a fixed point A above a smooth horizontal floor. The particle moves in horizontal circle on the floor with the string taut. The center O of the circle is vertically below A. With OAL equal to L as shown in figure. The particle moves with constant angular speed omega and remains in contact with the flow. Show that an inequality is given. So that means you know how to get that. When you read the question, you should get the idea, because the particle can follow a circular path, or particle can perform circular path without touching the flow also. It's not necessary to touch the flow, but here they are saying it's touching the flow. So that means there is a real value, real numerical value for the normal reaction from the flow. So only thing you need to find the R expression for the capital R or capital N you can use for normal reaction, R or capital N. If you say capital N is the normal reaction exerted by the ground on the particle, that should have a positive real value. It should be greater than 0. Equal to 0 is not a good, because equal to 0 means it's not in contact. So I feel it's better to say n, capital N greater than 0. From that you will get the expression what they ask to show the inequality, you will get it. When a particle moves on a circular path, you know, you must be able to identify the center of the circular path. Here it's mentioned that is O. O is the center of the circular path. Then you must be able to identify the actual forces acting on the particle. Then when you resolve all those forces towards the center, that will be the centripetal force, which is given by F equal mr omega squared or mv squared over. From either one we can follow the question, right? And also you should know, when a particle moves on a circular path, it has intention of moving away from the center due to its centrifugal effect. That's the reason for the tension in the string. Okay, so by using it we can continue. Nothing actually. I'm going to find the normal reaction exerted by the ground on the particle in terms of the other given quantities, and I'm going to take n greater than 0. From that I'll get that inequality. Okay, so the angle, we will take this angle theta. So from this we know that sine theta is equal, in this right angle triangle, sine theta is equal to L over 2L. From that theta equals sine inverse half. You know, LL will get cancelled, so it's going to be half. That means theta is going to be 30 degree. So from this sine inverse half, 30 degree. Okay, we know the angle made by the particle with the angle made by the string with the horizontal flow. Okay, so what are the actual forces acting on the particle? If you draw that, you must be able to identify, it's very important. The weight is acting on the particle mg, and there's a tension from the string. This is the tension from the string that makes an angle with horizontal. So the center is somewhere here, this is the center. So that makes an angle 30 degree with the horizontal, we found it. Additional to that, since the particle is in contact with the ground, there will be normal reaction. We will mark the normal reaction with capital N. Right, so these are the only 3 forces acting on the particle P when it moves on the circular path, such that touching the flow. Okay, so we'll continue further. So nothing actually, since the particle is moving on a horizontal circle, the resultant vertical force must be equal to 0 according to Newton's first law, because if there is a resultant vertical force either up or down, down can't be, it has to break the ground and grow, so that won't happen. So if there's a resultant vertical force upward direction, the particle will shift upward direction also, but that's not happening. That means according to Newton's first law, the upward resultant force must be equal to 0. So if I take upward direction, all the resultant forces must be equal to 0. Resolve them. T sine 30 minus mg, the normal reaction upward. So plus n equal to 0. N is the normal reaction. I'm using capital N for the normal reaction. Either capital R or capital N I can use. Okay, so from that I can say n plus sine 30 is half, t by 2 is equal to mg. We'll keep it as first equation because there are 2 unknowns. T is unknown, n is unknown. So I can't take any decision from this equation alone for the capital N. We'll try to find another equation that is related to centripetal force. So towards the center is the centripetal force, that is T cos 30. T cos 30. N is a vertical force that has no horizontal component. mg is the vertical force that also won't have a horizontal component. So this is the only force providing the required centripetal force. T cos 30 is equal to m r omega square. Okay, but what is the r? This is the r. This is the, so in this right angle triangle, r is equal to, but r is equal to 2l cos 30, theta is 30, 2l cos 30. So that is going to be 2l into root 3 by 2. So that's going to be L, root 3 is the radius. So therefore, T is going to be, I use this equation again, T cos 30. So cos 30 again, root 3 by 2. Root 3 by 2 is equal to M into R, that is L root 3 omega squared. So it's going to be T is going to be, T is equal to 2 ml omega squared, or we can say T by 2 is equal to ml omega squared. Let it be second equation. Substitute second equation in the first equation. So if I substitute the second equation in the first equation, n plus T by 2, that is ml omega squared, equal mg. So that's going to be n is equal to mg minus ml omega square, mg minus. Okay, so now I can say, since the particle is moving on circular motion such that it touches the floor, since the particle touches the floor, since the P touches the floor, n should have a real value. N must be greater than 0. We can put equal sign, but equal to 0 means almost left. We'll keep it as greater than 0. So that means mg minus ml omega squared greater than 0. That is m get cancelled because it's a positive quantity, so sign won't change. So g minus l omega squared greater than 0. So g must be, so that means I can write the other way, L omega squared less than G, omega squared less than G over L. That's the thing, no? So that means if I take square root of it, omega must be less than square root of G over L. Equal sign we can put, but we put equal sign, it has become 0. The normal reaction has become 0. Since the question paper asking that, I will put that also. But normally, if you want to strictly say it's not in contact, so there should not be any equal sign anyway, but I will put it. Okay, question number 3. A particle P of mass m kilogram is initially held at rest at a point O on a smooth inclined plane. The plane is inclined at an angle alpha to the horizontal where sine alpha given 2 by 5. The particle is released from rest and slides down the plane against a force which acts up towards O. So that means there's an opposing force which is given by 1/3 of mx squared. Okay, so if I put it on a diagram, this is the plane that makes an angle alpha with horizontal and sine alpha given 2 by 3. A particle is released from rest. So initially the particle was at rest. So when during its motion, say when it is at a distance x along the slope, there is opposing force, that is 1/3 mx squared Newton, and there will be another force, that is mg sine alpha, you know that. And also we know that sine alpha is given as sine alpha given as 2 by 5. Okay, so where x is a meters, is the distance of P from O. So I'll name that. This is O, the initial point. This is O. The name of the particle is P, right? So it has moved a distance x from the equilibrium. So the opposing force, we can say opposing force, like resistive force, I'll put R equal to 1/3 mx squared Newton. Okay, so they are giving that the force has magnitude 1/3 mx squared Newton, where x is meters in the distance of P from O. So this is the particle P from O, and P is the mass in kilogram. So students, those who are doing physics might get confused if you try to check the unit. This is given the opposing force 1/3 mx squared. The unit of m is kilogram, they are telling it. X is in unit of meter. So the unit of the opposing force is kilogram meter squared. Yeah, but we know that the force SI unit is Newton. So Newton means in terms of base units, it must be kilogram meter second minus 2. In those are in physics, in unit 1 you would have learned that SI unit of force is kilogram meter per second. Sorry, I made a mistake. The SI unit of force is Newton. Its base unit is kilogram meter second minus 2. But the unit of Fr is given 1/3. It's a number mx squared. The mass kilogram. So the Fr, unit of Fr, if I consider, that is kilogram meter squared. Anyway, I don't know why they are telling kilogram meter squared cannot be the unit of Newton. But anyway, as maths paper, we don't need to worry about these things. Since the reason I told is, friends, those are doing physics, they sometimes ask how can it be a Newton. But anyway, you don't need to worry about it. You just do it, you will get the answer. Okay, anyway, we'll forget about it. That we don't need to worry about it anything. It won't affect any answer. Only thing, friends, those are doing physics might get confused. That's all. Okay, so the question is, A part, find the speed of P when x equal to. That means when it moves a distance 2 meters, x is given in meters, 2 meters. What is the speed? That is the question. Okay, this we can do in two different ways. The first method by using energy equations. The second method by using F equal ma or F equal mx double dot. Either way we can do. I'll do them for both methods. So first part, that is A part. If I use the energy equations, that's very simple. Actually, if you are going to Newton's second law, the working will be a little more, but you will end up with the same answer. So when it moves down, what is happening? When the particle moves down along the slope, it was released from rest. The question is, find the speed of the P when x equal to. So when it moves down, its speed is going to increase because it's already at rest. So its speed should increase, is it? So its speed is going to increase. Its height is going down, and also it's going to experience an opposing force. So how can we relate the energy equations? Loss in gravitational potential energy, because it's going down, it's moving down. So loss in gravitational potential energy is equal to gain in kinetic energy, because speed is going to increase, gain in kinetic energy plus work done against opposing force, work done against opposing force. So when it is losing the gravitational potential energy, two different things are happening, or the loss in GP is converted into two other formats. What are they? Gain in kinetic energy and work done against friction, or work done against opposing force. So loss in gravitational potential energy equal to gain in kinetic energy plus work against opposing force. Alright, I started here, you can save space. Loss in gravitational potential energy equal gain in kinetic energy plus work against opposing force. Fr, I put opposing force, I showed it Fr, so I use that one. Loss in GP, imagine it has gone down along the slope x. So if it has moved down along the slope x, so the height h is equal to, we know this angle alpha, h is going to be x sine alpha. So that is mg h. H means x sine alpha. We know the x. Anyway, it's going to be 2 meters. I'll substitute later. Mg x sine alpha. Gain in kinetic energy, half mv squared minus half mu squared. Anyway, u is 0. plus work done against friction, work done against opposing force. So the opposing force is not it is not a constant force, it's going to be a variable. So the work done against opposing force is opposing force into the distance moved. So it's moving continuously small distances. So it's going to be an integration dx from 0 to 2. Okay, we'll continue. Mgx sine alpha. So x is going to be 2, I told that. So that is m mass is given. Okay, we'll see m mass is, yeah, will get cancelled when I substitute for the force. If I put m, that will get cancelled. So anyway, I'll substitute again mg. I substitute the g also, m into 9.8 into x is 2 because they asked to find the speed when it moves a distance of 2 meters. So I put x equal to sine alpha given 2 by 5 equal to half m v squared. I need to find when this distance become 2, that's a question. U squared equals 0, sorry, plus integral of 0 to 2 fr is 1/3 mx squared dx. Okay, we'll continue. M will get cancelled, so it's going to be 2 into 2, 4 into 9.8 over 5 is equal to half v squared because m got cancelled, plus m got cancelled, 1/3 integrated x cube by 3. The limits are 0 to 2. Okay, so that is 4 into 9.8 over 5 minus, take it to the left, 1/3 into 8. X to the power 3, 2 to the power 3 is 8 by 3 equal to half v squared. Solve it and get the v. You will get 3.73 meter per second. So this is the question number 3, A part, first part. Now A part, second part, I want to use Newton's second law there. F equal ma. We'll identify the forces acting on the particle along the plane down. So the forces acting on the particle along the plane down means, one force is acting upward direction, that's opposing force 1/3 mx squared. The weight has a component along the plane down, that is mg sine alpha. How mg sine alpha comes? It's a theory normally they do in the lesson. If there's a particle, its weight will act vertically down, that is mg. This is 90 degrees, this alpha means this is 90 minus alpha, is it? So this is 90 minus alpha. So the component of the weight along the plane down means mg cos 90 minus alpha, that is mg sine alpha. The component of the weight along the plane down will be mg sine alpha. So there will be two forces acting on the particle along the plane, which is downwards mg sine alpha, upwards 1/3 mx squared. When we do use F equal mx double dot, F equal ma, we use along the direction of increasing x. So x is increasing from this direction. So we use along the plane down means mg sine alpha minus 1/3 mx squared equal to mx double dot. From that I am going to get the answer for the question number 3, A part, second method. Okay, so method 2, A part. The forces acting on the particle along the plane down, I am going to use F equal mx double dot along the plane down. So what are the forces? The component of the weight along the plane down will be mg sine alpha minus the component, minus the opposing force, that is 1/3 mx squared equal to mx double dot. So all the m will get cancelled. G into sine alpha. So G into sine alpha, we know that 2 by 5 minus 1/3 x squared equal x double dot. So x double dot means dv over dt. So we know that x double dot equal dv over dt. That's going to be dv over dx into dx over dt. That is v dv over dx. So it's going to be v dv over dx. Okay, so we'll integrate it. Integral of v dv is equal to 2g over 5 integral dx minus 1/3 integral x squared dx. Okay, so students normally ask, what's the difference between integration with the limits or substituting plus constant? If you want to get a general equation, don't put the limits, because when you put the limits, you will end up with the final answer. If you want to get a general expression or general equation in terms of v and x, don't put the limits, put like plus c, then find the c by using the conditions given in the question. Then you can have a general equation that relates x and b. So I'm going to do that way, because for the b part, I can use the same equation again as one of the methods. Okay, so if I want, I can put the limits, no problem. By using the limits also, I'll get the same answer for a part in this method. But I want to get a general equation because I can use the same equation for the b part also as one of the methods. There are b part also could be done in two different methods, energy equation, F equal ma. So I can use the same equation again in the b part. Okay, so I'll put plus c. So it's going to be v squared by 2 is equal to 2g over 5 x minus 1/3 x cubed by 3. So it's going to be x cubed by 9 minus x cubed by 9 plus c. Okay, so I'll put x cubed by 9 together. X cubed by 9 plus c. We know that when the particle was initially at O, x equals 0, and it was released from 0. So I know that condition. So when x equals 0, we know that v equals 0. From that I'm going to find the c. So x equals 0, v equals 0. Substitute here, you will get everything 0. v equals 0, 0 equal x equals 0 plus x cubed 0 plus c. So from that c equals 0. So the general equation I'm going to get now, v squared by 2 equal 2g over 5x 2g over 5x minus x cubed over 9. So it's going to be a general equation. I can multiply by the denominators to remove the denominator, but it's okay, but it's going to be a general equation. I can use this equation for the second b part also. If I put the limits, I won't end up with this one. These values will be substituted, so I won't be able to get a general equation. You can decide which method you want to follow. Okay, so now the question is, find the speed when x equal 2. Now substitute x equal 2 and find the v. So I'll substitute here. So I'm going to find the speed when x equal 2, right, x equal 2. I need to find the v. So v squared over 2 equal 2 into 9.8 over 5 into x equal 2 minus 2 cube, that is 8 over 2 cube, 8 over 9. Solve it, we'll get the same answer, that is 3.73 meter per second. Okay, so this is the A part, second method. Now B part, I'm not raising it because I'm going to use the same equation I told as a first method. B part, the particle first comes to instantaneous rest at the point A. Find the distance OA. Okay, now you might ask why the particle is coming to rest. Think carefully. Now when you release the particle initially, at the moment you released, there is a component of the weight downward, mg sine alpha. At the moment you release x equals 0, so that time the opposing force is 0. So there is a downward resultant force, unbalanced force downwards, which is equal to mg sine alpha, the component of the weight. That component of the weight is constant, so it will accelerate down. So when it moves down, x will increase. When x increases, the opposing force is going to increase, is it? The opposing force is going to increase. So when the particle moves along the plane down, the weight remains unchanged. The component of the weight along the plane downwards, which is mg sine alpha, will remain unchanged, but x is going to increase, so opposing force will increase. So there are only two forces acting on the particle. One is the component of the weight downward direction along the plane. The opposing force is the force which is acting upward direction. This is remaining constant. But when it moves down and down, x will increase. X is the distance from the initial point O. X is increasing. When x increases, opposing force increasing means constant minus a force that is increasing means the resultant force will increase. So when the resultant force increases, what happened? There will be a point at which these two forces will become equal to 0. Until that, the particle will move. Until that the particle will accelerate. They can ask, in the same question, they can ask, find the maximum speed. Something like this question appeared in the previous paper, I can't remember which year. Find the maximum speed. They can ask, but they didn't ask that. They can ask, find the maximum speed during this motion. So the maximum speed will occur, the particle will accelerate downwards until the opposing force becomes equal to component of the weight. There will be a downward resultant force, so the particle will accelerate. At a point, both will become equal to 0. At that moment, instantaneously, the acceleration will become 0. But the particle has the highest speed at that point. So the particle will move further down because it has speed, but the forces are balanced, but particle has a speed, so it will move further down. When the particle moves further down, what's going to happen? X is going to increase further. When x increases further, the upward force is now becoming greater than the component of the weight downward. So the upward force become greater means the opposing force will become greater than the component of the weight means the resultant force will be upward, the motion is downward. Whenever any moving object that has a force opposite to the direction of motion, here the particle is moving down, the force is acting up, which is opposite to the direction of motion means the particle or object will decelerate. So whenever something decelerates continuously, it will come to rest at a point. So that's the question they ask me. Find the distance at which, the question is, the particle first comes to instantaneous rest at a point A. So it will move down continuously because of the opposing force has become greater than the component of the weight. So there is a resultant force upward direction which is opposite to the motion. So it will decelerate and it will come to rest somewhere here. That point is A. So it will decelerate and come to rest somewhere here. This is the point A. So they ask you to find the distance x where the particle becomes 0. This distance d, something like that, they ask you to find. So at that moment, instantaneous it will come to rest. At that moment, we know that this force is greater than weight. So after it comes to rest, it will start to accelerate upward because this force is greater than weight. So it came down, comes to rest. But still at that point, this force is greater than the component of the weight. So the resultant force is upward. From rest, it will accelerate upwards again. It can perform an oscillation. Okay, so the question is, find the distance d when the particle instantaneously comes to rest. Okay, so question B, now this is B part. Now A part, this is B part, method 1. First method, B part, method 1. You understood the reason why does particle come to rest. You know that now. So I am going to use the same equation, this equation. I am going to use the same equation. So I can start from that, or I can refer this equation if you are doing first part, A part, method 2 if you have answered. You can use this equation again. Not that one, this equation. So this is the final general equation we got it, is it? In the A part, as a method 2, we got this equation. I am going to use this equation now. This equation now. What I am going to do, the question is, what's the distance of x when v becomes 0? So from this equation, you can find the x by substituting v equal 0. Because here we found what's the value of v when x equal to. Now we are going to find what could be the value of x when v becomes 0. Right, we will substitute. So that's the answer. That's a method 1 for the B part. I am going to use that same equation what I got in the second method, A part. Okay, so that's the advantage of integration without any limits. You can use a general equation. Okay, so now I am going to see this one, B part, method 1. From this equation, b squared by 2, I am writing it again, 2gx over 5 minus x cube over 9. So when v equals 0, I need to find the value of x. So 0 equal 2g over 5 minus x squared over 9 into x. I took x out. Okay, so because I can take this is 0, here x cube, I took x out. So one of the solution x equals 0. Yes, that's true. X equals 0 is a solution. What is it? Initially the particle was at rest. So that is the solution. When v equals 0, x equals 0 is a correct solution. But that's not the answer, because that we know already. It was at rest initially. So x equals 0, leave it. We will find this one. So that is x squared by 9 minus 2g over 5 equals 0. Substitute x squared over 9. Take the other side, 2 into 9.8 over 5. Solve for x. Solve it and take the square root of it. You will get the answer. So you will get x equal 5.94 meters. This is B part, method 1. Okay, question number 3, part B, method 2, that is based on energy equations. Okay, so this is method 2. Okay, so what's the energy equation? The particle was released from rest. When it moves down, I told in the first method, the particle's speed will increase. So speed increases means its kinetic energy is increasing, the particle is moving down along the slope, so its gravitational potential energy is decreasing. So when we consider the motion from initial point O to A is the point at which it's coming to rest again, momentarily coming to rest. So what's happening? The speed of the particle increase, so it gains kinetic energy when it loses the gravitational potential energy. But again the speed is decreased. I already explained why the speed decreases beyond a point, because the opposing force becomes greater than component of the weight along the slope down. That will make the particle decelerate. So finally there is no kinetic energy. So what happened? When it moves up to a certain distance, it gained kinetic energy, but all the kinetic energy gained again lost due to work done against the opposing force. So when I relate the initial point O and the final point A where it comes to momentary rest, the energy equation I can write loss in GP. It's losing the GP because it's moving down. All the loss in GP has become work done against opposing force. No kinetic energy, because it would have gained kinetic energy up to a certain point. The kinetic energy it gained is lost again. So overall, when I consider the motion from O to A, I can write loss in gravitational potential energy equal work done against opposing force. Gravitational potential energy equal work done against opposing force. I name it F. Okay, loss in GPE. So it has moved down a distance d. I need to find the d. So when it moves along the slope d, it lost GPE, that is equal to mg d sine alpha. The height will be d sine alpha. So mg d sine alpha is equal to work against opposing force Fr. So that is opposing force Fr into the distance moved dx. Okay, so I need to integrate. So the total distance moved is from 0 to d. I don't need any general equation here, so I'll put the limit there. Okay, so we'll solve it. Mg d sine alpha. So mg d sine alpha, that is m anyway will get cancelled. Sine with the Fr as m. Sine alpha 2 by 5 equal to Fr 0 to d. Fr equal to 1/3 mx squared dx. Okay, so that's going to be m will get cancelled. 2g d over 5 is equal to 1/3 x cubed by 3 from 0 to d. Okay, so I need to find the d cube. So that means here 2g d over 5 equal 1/3 into 19 into x cube means d cube minus 0. So d squared. So it's going to be d squared is equal to cross multiply. So d cube will become d squared. So 2 into g is 9.81. 2 into 9.81 cross multiply into 9 over 5. Find the d, you'll get the same answer. .94. Okay, question number 4. This diagram is given. The height is Ka. A thin, uniform, rigid, hollow cylinder of radius 2a and a height Ka has a base but no top. That means there's a base but the top part is removed. So it's one end open cylinder. Has a base but no top. A thin uniform hemispherical shell, this one hemispherical shell, also of radius 2a, so its radius also 2a, is made of the same material. So that means mass per unit area is the same, is made of the same material as the cylinder. So it's not a volume, so it's like a surface because it's not a solid object, it's a hollow object. The hemispherical shell is attached to the end of a cylinder forming a container C. This is the container named C, the whole thing. The open circular rim of the cylinder coincides with the rim of the hemispherical shell. The center of the base of C is O. So this is O. So this is the C. The whole object is called, the container is called C. As shown in figure 3, show that the distance from O to the center of mass of C, they are given an expression k square plus 4k over. Okay, we have to show that. Anyway, the principle here is sigma mixio, sigma mi. So there we need to identify. So I told that we can do it for tiny particles or even objects. So I can say this container C is made of 3 different objects. What are they? I can imagine it's a hollow cylinder, both ends open hollow cylinder. Then a circular disc, that is the base of the cylinder. So I can imagine the cylinder as 2 different objects. One is a hollow cylinder, both ends open. Then a circular disc, then a hemispherical shell. So all these 3 forms the container C, right? So we need to find it. So we'll find the mass of each and every objects. There are 3 objects again. One is hollow cylinder such that both ends are open. Then circular disc, the bottom of the hollow cylinder, there is a material there. Then hemispherical shell. Okay, we'll find their mass. Then we'll use sigma mi xio, sigma mi. So it's not a big issue, right? Okay. So we'll find one by one. First we'll find the surface area of the hollow cylinder, both end open hollow cylinder. That's easy. Actually, you can imagine if I form a hollow cylinder by using this paper, it will come like this. This is a paper. So its surface area is equal to width into height. You see, if I can form a hollow cylinder by rolling like this. So the surface area of this hollow cylinder is this length I need to find, that is 2 pi r into height. Is it? So surface area of hollow cylinder, both ends open hollow cylinder, surface area of both ends open hollow cylinder equal 2 pi into 2a 2 pi r. So that is the, if I imagine if I cut the hollow cylinder something like this, I can make a hollow cylinder of both end open by using this sheet paper, is it? So 2 pi r, that is the length, is it? 2 pi into 2a into ka. Okay, so I can imagine mass per unit area rho. So mass of this, I don't want to write again, mass of this cylinder that is 4 pi k 4 pi k a squared. Rho is the mass per unit length. Okay, so I can keep it as equation 1, expression 1. Okay, so that's the bottom end is closed. So mass of circular disc, or yeah, equal its surface area pi r squared, pi into 2a pi r squared into rho. So and that is going to be 4 pi a squared rho. Okay, so the mass of hollow hemispherical shell equal, I need to find the surface area of it. So the surface area of a hemispherical shell is, for a hollow sphere or sphere, the surface area 4 pi r squared. This is half of it. 4 pi r squared divided by 2, 2 pi r squared, is it? So it's going to be 4 pi r squared divided by 2, that is 2 pi r squared. R is 2a, so 2 pi into 2a all things squared into rho, same material, so same mass per unit area. So it's going to be 8 pi a squared rho. Okay, so I need to find the total mass of the C, the container, total mass or mass of C. That is, I can call M. Okay, so mass of C, M. That is going to be, add all these three. So that is 4 pi Ka squared rho plus 4 pi A squared rho plus 8 pi A squared rho. So that's going to be so take the 4 pi out, anyway, that's not a big issue. 4 pi Ka squared rho, 4 pi A squared rho, 8 pi A squared rho, it's going to be 12 pi A squared rho. So I can take 4 pi A squared rho if I take it out. So it's going to be K plus 3. Okay, so I want to use the same principle, that is center of mass x bar is equal to sigma mi xi, generally over sigma mi. If you cross multiply, x bar into sigma mi equal to sigma mi xi. So I'm going to use that principle. So x bar is the center of mass of the container C. Sigma mi is the total mass. We found it equal to sigma mi xi. Sigma mi xi means each and every object involved, or each and every object that forms the container C, their mass into their center of mass, distance of center of mass from the same point. So I'm going to find the center of mass from O. So center of mass from O for the C, I took it as x bar into sigma mi is the total mass. Then m1, the mass of the bottom surface area, that is the disk, that is at O. So the distance of the center of mass of the base disk is from O is going to be 0. So 0 into that mass plus the mass of the hollow both ends open cylinder that we found it into here. This is the mass of the hollow cylinder, 4 pi Ka squared rho. And its center of mass, uniform cylinder, hollow cylinder, center of mass will be at half of the height, is it? At the center point. So from O, it's at the half of the height, means Ka by 2. Then mass of the hemispherical shell, that's we found it, mass of the hollow hemispherical shell, we found it. Its center of mass from its center, base of the center, is given in the data sheet, that is equal to half of the radius. From here, the distance of the center of mass is half of the radius. So from O, half of the radius, that is half of the 2a into plus Ka. Okay, I'm going to use that one. I'll get the final answer. Okay, so we'll use that idea here. So x bar, that's the center of mass of this container C, into the total mass 4 pi a squared rho k plus 3 equal to sigma mi, mass of the bottom disk into 0. So I don't need to write anywhere else. I write that mass of the circular disk 4 pi a squared rho into 0, because we are finding center of mass of the whole system from O. So the center of mass of the base disk is at O. The distance of center of mass from O is 0, is it? So that was 0 plus center of the mass of the hollow or both ends open cylinder is 4 pi Ka squared rho into the distance of the center of mass of this hollow cylinder from O is K by Ka, the height, half of it, half of the height. So that is Ka by 2 plus the mass of the hemispherical shell. We know that hollow cylinder 8 pi a squared, 8 pi a squared rho into the distance of center of mass of hemispherical shell from this point is half of the radius. So half of the radius, yeah, that's the way it's given in the data sheet. I'll check it again. Yeah, half of the radius means from O, Ka plus half of 2a. So that is Ka plus half of the radius, so 2a. Okay, so we need to solve a lot of things are there. We need to solve and get an expression for x bar carefully. The whole equation can be divided by 4 pi a squared rho. So 4 pi a squared rho here, anyway this is 0, we don't need to integrate. 4 pi a squared rho get cancelled. Here 8 pi a squared means 4 pi a squared rho, if you take, it will end up with 2 into Ka plus a, is it? So we'll do that. So it will come like x bar into 4 pi a squared rho. I'm going to divide the whole equation. So into k plus 3 here is equal to 4 pi a squared rho 0, we don't need to find. 4 pi a squared rho means k remaining, k into k squared a squared, k squared a by 2 plus here there will be 2, 4 pi a squared rho on. So 2 into a, you can take it out. So 2 into 2a in bracket k plus 1. I think I'm right. Okay, so solve this one right side. if you take 2, so Ka squared 4a, so that is Ka squared plus, if I take 2 as a LCM, 4ak, 4Ka, sorry, 4Ka plus 4a, is it? 4Ka squared, yeah, not a squared, Ka, right, K squared a, sorry, K squared a, K squared a plus 4 Ka plus 4a over 2. Okay, so we'll finish it. Now we'll divide the whole equation by this one. So we'll get x bar as a subject. If I take the x bar as a subject, final answer x bar is equal to k squared. I can take the a out, so that's going to be k squared plus 4k plus 4a over, this 2 is there, 2 into k plus 3. That's the answer they asked to show. We got that answer. Okay, question number 4, B part. It's about something related to toppling. Okay, stability. In IGCSE physics, you would have learned that, for example, if there's an object something like this, if it has a larger base, whatever normally we teach why a lamp or a pedestal fan needs a larger base. For example, if there's an object something like that kept on a floor on it, in the center of mass, if it is somewhere here, and if it is just tilted something like this, when it is tilted something like this, so this is the point at which it's touching the floor now, so the normal reaction will be here. If the center of mass of the object is somewhere here, the line of action of the normal reaction is along this line. If the center of mass of the object is somewhere here, then we say the object is at stable position, because if I consider moment about this point, due to the weight it will return, there will be a clockwise moment, it will return to its initial position. But if the object is tilted further something like this way, if it is tilted further something like this way, and the center of the normal reaction will be somewhere here, this is the flow, the normal reaction will be somewhere here, the normal reaction, I'll use capital N, the weight is somewhere here, the center of mass is here. So what happens when I consider moment about this point, what happens, the weight will produce an anti-clockwise moment, so it will topple. So remember that if the weight provides a moment this direction, something like the way when you topple, if the weight provides a moment opposite this way, if the weight is somewhere here, the normal reaction, the center of mass is here, the contact point here, normal reaction here. So when I consider moment about point, if the weight provides a clockwise moment, it will return to its original shape or initial position. It's very stable. Here this is unstable because weight will topple it, so it will fall down, it will topple. If the weight is passing through the same line of action of the normal range, the center of mass is here, the weight is passing through the line of action of the normal reaction, then we can say it is almost in the limiting equilibrium in terms of toppling, or we can say it's almost going to topple. So that is the condition we need to take for B part. If it is what, if it is at now that they are saying the question, the container is placed with its circular base on the plane which is inclined at 30 degree to the horizontal. The plane is sufficiently rough to prevent C from sliding. Yeah, here also when you tilt like this, it can slip, but we assume it's not slipping. So under that condition only we can talk about the toppling. So 30 degree to the horizontal, the plane is sufficiently rough to prevent C from sliding. The container is on the point of toppling, so it's almost going to topple. Means, remember that whenever you get a question like this, the normal reaction and the weight should be on the same line of action. Okay, you'll draw a diagram based on that. Okay, so if it is almost going to topple, this is the condition. So the line of action should pass through that. So tan 60, this opposite OG over OA. Okay, so tan 60 we know that is 1 over root 3. So tan 60 equal to 1 over root 3. You can get it from the calculator. 1 over root 3 is equal to this 2a will go up. So A and A will get cancelled. Tan 60 root 3, tan 60 root 3, not 1 over root 3. So root 3 is equal to, so this comes down, so that is k squared plus 4k plus 4 into A divided by 2 into 4 k plus 3 into A. So A and A will get cancelled. Solve it, cross multiply. So 4k into root 3. So 4 root 3 k plus 4 into 3, 12. 12 root 3 is equal to k square plus 4k plus 4. Yeah, so solve it. It's a quadratic equation. So rearrange it. So k square plus 4k minus this one, bring it to the right, you solve it, that is okay, minus 4 root 3k plus 4k minus 12 root 3 plus 4 equals 0. So solve it, you will get finally the quadratic equation k squared minus 2.93k when you solve these two minus 16.8 equals 0. By using calculator, you can solve this quadratic equation. You will get k is equal to 5.82 or k equal negative 2.90. But since k is a positive quantity, because the height is given as ka, can't be a negative answer. So the final value of k is 5.82. So remember the idea, the normal reaction and the weight should be along the same line of action if the object is almost going to topple. Okay, question number 5, it's related to simple harmonic motion. A particle P is moving along the x-axis at time t seconds. The displacement of P from the origin O is x meters, where x equal 4 cos 1 over 5 pi t. So the question number 5, they are saying x equal 4 cos 1 over 5 pi t. Okay. A part prove that particle P is moving with simple harmonic motion. So if you want to show it is moving with simple harmonic motion, we should get an expression that acceleration x double dot equal minus omega squared, a constant, a number into x. We have to get that format. So here the equation for the displacement with time is given. So displacement, when you differentiate with respect to time, you will get the speed, velocity. When you give it differentiate again, the second order diffraction of displacement will give the acceleration. We'll try that way, we'll get it. So the part dx over dt, normally denoted by x dot, is equal to, differentiate it, minus 4. If you differentiate this inside part, it will become into 1 over 5 pi sine 1 over 5 pi t. So that will be minus 4 pi minus 4 pi over 5 sine 1 over 5 pi t. Okay, so differentiate it again, d2x over dt2, that is d2x over dt2, that is x double dot, that's acceleration. It's going to be minus 4 pi by 5 into, differentiate this again, you get 1 over 5 pi into cos 1 over 5 pi t. So it's going to be, we'll rearrange it. So the 4 cos, that format we had to get it. So we'll write this, take the 4 there. So that is pi into pi squared. There's minus sign. This minus, because I want to get in terms of x. Is it x double dot equal to some constant into x? So this x means there's a 4. So I have to bring the 4 here. So pi squared over 5 into 5, 25 times 4 cos 1 over 5 pi t. So we know that, I think I made a mistake. It's correct, yeah. So minus pi over square. So it can be minus pi squared over 25 or pi over 5 all things squared. Anyway, I can write minus pi over 5 all things squared times 4 cos 1 over 5 pi t. 4 cos 1 over 5 pi t is equal to x. So into x. So this is in the form. This is a constant. Pi over 5 is a constant. Since pi over 5 is a constant, it's in the form of x double dot equal minus omega squared x, where omega equal pi by 5. So that means x double dot directly proportional to minus x. Therefore, it is simple harmonic motion. That's the thing you have to conclude finally. X double dot, that is acceleration, directly proportional to negative x. Okay, B part, find the period of the motion. So period of the motion, we can find it. Omega, we got it pi by 5. So B part, omega equal 2 pi over t. We know that omega equal 2 pi over t. We know that omega equal 2 pi over t. That is pi over 5, pi by 5. So from that, t is equal to 10 seconds. C part, state the amplitude of the motion. Okay, so state amplitude. So this is in the standard format of displacement. X equal, you have that in the data sheet, x equal a sine omega t or x equal a cos omega t. So this is in the form of x equal a cos omega t. So a is the amplitude. So there's nothing to do calculation. So amplitude is equal to 4 meters. That's what they are giving only just 1 mark. Just compare the standard equation with the given equation, so we can get the amplitude. Even by comparing it, we can find the omega equal 1 over 5 pi. We got that omega equal pi by 5. Yes. Right. Find in terms of D part, find in terms of pi the maximum speed of the particle. So we know that equation for the speed v squared equal omega squared a squared minus x squared. So maximum speed occurs when x equals 0. So V max occurs at the equilibrium position omega squared into a squared minus 0. That means x equals 0. That time we will get the maximum, because the portion which is getting subtracted becomes 0. You will get the maximum. Okay, omega squared, we know that omega squared equal pi squared over 25 into a square. We found the a square, that is 16. So find the V max. So that's going to be pi by 5 into 4. So if you solve it, you will get 2.51. Okay, part E, they are saying the points A and B lie on the x-axis on opposite sides of O, with OA 1.5, OB 2.5. So A and B are not the extreme positions. That is, extreme position means the positions with maximum displacement, because the amplitude we found it 4. So this is smaller than 4. Both sides 1.5 and 2.5 are smaller than 4. So they are not the extreme positions. So if I consider this as the O, so A is on the left side 1.5, either one, this is 1.5, and B is 2.5. So this is 2.5 meters, but the extreme positions are somewhere here. They are with 4 meters from the O, right? Find the time taken by P to move directly from A to B, directly from A to B. Okay, so if there are extreme positions, there are two equations we have that relates the displacement and the time. One is x equal A cos omega t, the other one is x equal A sin omega t. You should know where to use which equation. We use this equation to find the time taken by a particle to move from maximum displacement position to some other position. Say for example, if this is the equilibrium position, a particle has amplitude A, so this is x and y are the extreme, or P and Q are the extreme positions. You know the displacement is always measured from the equilibrium position. If a particle wants to move from Q to some other point, say that Q from O is capital A, that amplitude is A. So from O to Q is A. If a particle wants to move from Q to a point B, say maybe the B is at a distance of A by 4. So how long will it take to move from Q to B? If they ask, we should use the equation x equal A cos omega t, because when you put t equals 0, x equal A. So t equals 0 means initially it is at the extreme position where x equal A. Then later at time t, what will be the displacement, which is A by 4 from O. Careful, here in the simple harmonic motion, the displacement is measured from the equilibrium position. So at x equal, when t equals 0, x equal A, what's the time? They can ask, what's the time when x equal A by 4? If they ask that question, you have to use x equal A cos omega t. Remember that always displacement is measured from the equilibrium position. Students have confusion because O level you learned the displacement means the shortest distance between initial and the final point. So students think when it moves from B to Q, this is the displacement, Q to B. No, that is not the displacement. Displacement is measured from O. O is the reference point. We take it in simple harmonic motion. The meaning of this equation is when t equals 0, the displacement is x, displacement is A. Then at time t, the displacement is x A by 4 from O, remember that way. So if the question is something like that, what's the time taken to move from Q to B, then you have to use this equation A cos omega t. So the particle has to be at the maximum displacement position when t equals 0. So in that situation, we use x equal A cos omega t. But if you want to find a time taken to move from O to B, means x equal A sin omega t we will use. When t equals 0, x equals 0. So if they ask to find the time taken by the particle to move from O to B, where this displacement is A by 4, then we will use x equal A sin omega t. When t equals 0, x equals 0. How long will it take to have a displacement of A by 4 from O? Then we will use A sin omega t. Okay, so always displacement is measured from the equilibrium position. But in this question, and also you must know that, very important, the time taken to travel between 2 points is the same regardless of direction of motion. That is, the time taken to move from O to B is same as from B to O. Remember, the time taken to move from O to B is same as the time taken to move from B to O. Then you consider just 2 points. Say for example, in the simple harmonic motion, just 2 points. This is point say name L, this is point M. The time taken to travel from L to M is same as the time taken to travel from M to L. So the time taken to travel, move between 2 points in a simple harmonic motion does not depend on the direction of motion. Okay, that also you must know. So here we can use this equation when the particle initially at the extreme position, but here the particle is not at the extreme position. They are saying the time taken to travel from A to B directly. They are asking A or B, neither is the extreme positions. So which equation should I use? I can't use cos because it's not moving from the extreme position. Extreme positions are here because amplitude, we found it, the amplitude of this motion is 4 meters. So the time taken to move from A to B is the question. So the time taken to move from A to B, if you want to find, we will find the time taken to move from O to A. O to A. We take, assume the particle was at O. How long will it take to travel from O to A? We will find it. The time to travel from O to A is same as A to O. Same way, the time taken to travel from O to B is same as B to O, but anyway, we need to find O to B. So the time taken to travel from A to B is same as time taken to travel from A to O plus the time taken to travel from O to B. So we'll use the sine equation, not the cos here. Okay, so we'll take the time taken. So we'll find the time taken to travel from O to BA. So x equal A sine omega t. So TOA, O to A, TOA equal A amplitude, you know, 4 sine. Omega we found it pi by 5, I think. Yeah, pi by 5. Sorry, I am x that is x equal O to A, that is 1.5 equal 4 sine omega pi by 5 time OA, we will find it, time OA, not AO, OA we will find it. The time of OA is same as time from A to O. Okay, solve it and get the time of that one. TOA will be equal to, we have to solve this by using calculator in radian mode. Calculator should be in radian mode. So you will get it 0.61. So time A to O is also the same, 0.61 second. Okay, so we'll find next the time taken to travel from O to B. So x equal A omega t. So that is O to B, we consider that is 2.5 equal A 4 sine pi by 5 T O B. We'll find T O B. Solve it, you will get 1.07 seconds. So the time travel from A to B is time from A to B is equal to time from A to O plus time from O to B. Time from A to O 0.61 plus O to B 1.07. Solve it, you will get 1.68, the 68, yeah. Okay, question number 6. A particle P of mass 1.2 kg is attached to the midpoint of a light elastic string of natural length 0.5 meters. So that's a natural length 0.5 meters. And the modulus of elasticity lambda newtons. The fixed points A and B are 0.8 meter apart on a horizontal ceiling. So on a ceiling they are connected to 2 points A and B. Particle is attached at the center. The particle P of mass 1.2 kilograms attached there. Okay, anyway, A and B are 0.8 meter apart on the horizontal ceiling. One end of the string is attached to A and other end attached to B. Initially, P is held at rest at the midpoint M of the line AB. So the particle P is at a point M. The M is the midpoint of the AB. It's at rest and it's held there, not hanging. The tension in the string is 30 newtons. So when it is extended to points A and B, the tension in the string is given 30 newton. Okay, so the distance between A and B is 0.8 they are saying. So that's now the length of the string. The actual natural length is 0.5. So the extension of the string. So first part show that lambda. So A part. So the extension x is equal to 0.8 meter minus 0.5 meter, that is equal to 0.3 meter. That's the extension of the whole string, the total extension of the string. So we'll use the equation T equal lambda over L into x. Tension given 30 newton. we need to find the lambda. Natural length is 0.5. Extension is 0.3. Find the lambda. You will get 50 Newton. That's the first part answer. B part, the particle is now held at rest at the point C, where C is 0.3 meter vertically below M. So now that means they allowed it. So the string, the particle P is going to move down. The string is going to be something like this. This length is given, which is 0.3 meters. The particle is released from rest. So they are pulling it down and they are releasing it. Find the magnitude of the initial acceleration of P. So we need to find the resultant force acting on it. Then we are going to use Newton's second law, F equal mx double dot. So I'll draw the diagram for the B part. So this first part is over. Lambda is 50 Newton. We found it now. So initially AB, the distance between AB was 0.8 meter. So M was the midpoint. So this distance, this length will be 0.4 meters. So this will be 0.4 meter. Same way this also 0.4 meter. This is the point M, the midpoint of it. Okay, so this length is 0.3 meter. They are saying it's pulled down through 0.3 meter. So the CB will take it D, so this also D. Now the total length of the string is 2D. The total length of the string after you pull the particle to the point C, the total length of the string is 2D. We'll find D, how much is it? So we use the Pythagoras theorem for this triangle. D squared equal 0.4 squared plus 0.3 squared. So D will be 0.5 meters. Okay, so D 0.5 meters means the question is they asked to find the initial acceleration. We need to find the total force acting on it towards upward direction. Is it on the particle P? So the distance is, the length CB is 0.5. So the total length now, equals 0.5 plus 0.5. That is 1 meter. So what is the new extension? New extension equal 1 meter minus 0.5 meters the actual natural length. So the new extension x equal 1 minus 0.5, 0.5 meter. Okay, so what could be the tension of the string? We can find it. Tension is equal to T equal the new tension T equal lambda over L into x. So lambda we found it 50, the first part. L we know 0.5 meter. Extension now, the total extension is, we found it, D we found it on one side, CB that is 0.5. Total length of the string is 0.5 plus 0.5, which is 1 meter. 1 meter minus 0.5 is the natural length. So if you subtract the initial length, you will find the extension, which is 0.5 meters. So the tension is going to be 50 Newton. Okay, so when I draw the free body force, the actual force is acting on the particle, the weight is acting downwards, mg, we can substitute the value of mg. So this tension T, which is 50 Newton, here this is 50 Newton. So this angle theta, this also angle theta, symmetrical. So how much is that angle theta? So we can find this cos theta. So the resultant force acting on the particle is 50 cos theta plus 50 cos theta minus mg, 2t cos theta minus mg. So cos theta we can find from here 0.3 over 0.5 we can find it. So from the triangle MCB, from the triangle triangle MCB, cos theta is equal to 0.3 over 0.5, that is 3 by 5. That is the cos theta. Okay, so the resultant force we need to find, because we are going to use F equal ma. Initial acceleration at the moment it's released. So we'll use this direction, F equal mx double dot. We need to find the x double dot initially at the moment it's released. So that is 50 cos theta, 50 cos theta plus 50 cos theta minus mg equal mx double dot. That's a solution. We are going to do it. So that is 50 into cos theta 3 by 5 plus I can do, or I can multiply by 2. Anyway, I write it for 3 by 5 minus mg. The mass is given 1.2 kilograms. So 1.2 into 9.8 equal 1.2 x double dot. Solve it, you will get the x double dot. That's the initial acceleration when it is released from C. So you will get 40.2 meter per second square towards M. Okay, so this is the answer for B part, question number 6, B part. Question number 6, C part, find the speed of P at the instant immediately before it hits the ceiling. So now you know that it has acceleration. When you release it here, this is the acceleration. So it's going to move until it reaches the point M. M is the center of AB. Until it reaches the M, there will be resultant force acting on it. So it will accelerate. So the speed will increase. Just before it hits the M, what could be the speed? That's the question when you release it from point C. Okay, this also we can answer in two different methods. One is by using the first method by using energy equations. The second method by using Newton's second law, F equal mx double dot. But actually energy equations are very simple to handle and easy to solve. But Newton's second law method, you need integration and the working will be more. But anyway, you will end up with correct answer. But anyway, either one you can choose. Okay, so C part, that is the C part. I'll do the method 1 by using energy equation. That is easier. Okay, what will happen when it moves from here to here? The extension is going to decrease. At this point, the extension we found is 0.5 meter. When the particle reaches M, there will be extension. We found it in the first part, that is 0.3 meter, because this length is 0.8. The natural length is 0.5. So at point M, the extension is 0.3 meters. At this point, initially 0.5. Initially means just before you release the particle, extension is 0.5. And we know that elastic potential energy is given by half lambda over L x squared, is it? So loss in elastic potential energy. So when it moves from point P to M, when it moves from point C to M, it's going to lose the elastic potential energy. How to find the loss in elastic potential energy? Initial elastic potential energy at point C minus the elastic potential energy at M. If you subtract, you will get the loss in elastic potential energy. So when it's going to lose the elastic potential energy, how it is going to be converted to other form of energy? The height is increasing, so it's gaining gravitational potential energy. It's released from rest just before hitting, it has speed. So the speed also increasing, so gaining kinetic energy. So I can write loss in elastic potential energy equal gain in GPE plus gain in kinetic energy. That's the energy. You must be able to identify the energy changes or the conservation of energy related equation. You should be able to identify what is loss, which is gain. Okay, so loss in EP half lambda over L x2 square. x2 means finally, which is x2. Now I can change it to x2, that is 0.5 minus lambda over L x1 square. x1 is 0.3. That is equal to mgh, gain in GP. H is 0.3 plus gain in kinetic energy half mv squared minus half m u squared. U anyway 0, you are releasing it from rest. Okay, so we'll substitute half lambda over L, I can take it out, half lambda over L, we know the value of lambda, that is 50. L is 0.5. x2 squared. x2 is 0.5 squared minus x1. Initially it was 0.3. First part we got that 0.3 squared equal to mass 1.2 into 9.8 into h. The height it's going to move is 0.3 from here to here into 0.3 plus half mass is 1.2 v squared minus initial kinetic energy it was released from rest, so minus 0. Okay, solve it and get the V all numbers. Only the unknown is V. Solve it. You will get V is equal to 2.73 meter per second. That's the answer. 2.73 meter per second. Okay, so question number 6, part D, method 2. Sorry, part C, method 2. That's part C, method 2. First method we use energy equations. Now we are going to use Newton's second law method. Okay, so we'll see it was pulled down. The particle P was pulled down below M through distance 0.3 meter and released. We'll take when it is at a distance x below M. Because you know the reason here, when the particle moves up and up, the extension is going to change. Extension changes means tension is going to change. When the tension changes, acceleration is going to change. Acceleration is not a constant. It's going to be a variable depending on the depth of the particle P below M. So that's the reason we are going to take it as a variable x at an instant. Then we'll proceed. So for example, so we'll take like this. So A and B are the 2 points. So this is A, this is B. So the particle is at a point x below that at an instant. This is the particle. So these are the two strings attached. We'll take the particle at a depth x below the M. This is the M. Below that it's at a depth x. Along the direction of x is measured from here. So from M x is measured. We take that direction. So this is the point M. The particle was initially. And this is the particle P, this angle theta. Let the this side P, the length D, so this is also D. This is MB 0.4, we know that already. Okay, so we need to find the tension, those things in terms of x. X is a variable. The x initially, x is 0.3. We need to find when x becomes 0, the speed we need to find it. So the particle moves this way, the x will decrease. X is measured from here, initially 0.3, finally 0. So the arrow is pointing down because we are taking the direction of x from M downwards. Okay, so there we'll take like this. So in that case, x, we can say the d, how much is the d? So we can, this is 0.4 meters. So d squared equal to x squared plus 0.4 squared. So d is going to be a square root of x squared plus 0.4 squared. We need cos theta when we find the compound of the tension. So cos theta is going to be x over d, that is square root of x squared plus 0.4. So more working, lot of working here. Energy equation is much easier, but anyway I'll do it. Okay, so the extension when the position of the particle is at x below M, what could be the extension? We can call the extension E. Extension E is equal to the D, 2D, that's the total length of the string now, 2D minus initial length, that is 0.5, that is the actual length is 0.5. So that is E is going to be 2D, means 2 times square root of x squared plus 0.4 squared minus 0.5 is the extension. Extension when the particle is at position at point here x meters below M, that's the extension. Okay, so what could be the tension at this moment? The tension at this moment T is going to be lambda over L into x, that is x means E, we put it here, we are using extension here E into E. So lambda we know 50, L we know initially 0.5 into E, that is 2, we put in a bracket, 2 into square root of x squared plus 0.4 squared minus 0.5, that is the tension. Okay, so I told the working will be very lot of working, but anyway we can do that. Okay, so right, so if I think about the particle, what are the forces acting on the particle? This direction tension T, this direction also tension T, the angle theta, same angle theta, the weight is acting downward mg. So we are going to use Newton's second law, F equal ma. We take along the direction of s. Remember that when we are using Newton's second law in terms of integration, where you have a variable force which depends on the distance, always take along the direction of the distance measurement positive. So I take from m downwards positive. So the position of the particle is measured from O, initially 0.3, finally 0. That's a limit I am going to put for x. So x is decreasing from 0.3 to 0. So along the direction of x, from m is taken positive. So mg is taken positive. So I'm going to use F equal ma, this direction, F equal mx double dot. F means mg minus t cos theta, so both will be upward, so I can write 2t cos theta, is it, because t here there's a t cos theta, both are pointing up, so I shortly wrote 2t cos theta is equal to mx double dot, we can change it later, v dv or dx. Okay, so that is mg, we know the mass, we can substitute, 1 point, I'll leave it like this, mg minus 2, instead of t I had to put this one, 50 over 0.5 into 2 square root of x squared plus 0.4 squared square root minus 0.5 cos theta. Cos theta we got it, x over square root of x squared plus 4 squared, x squared plus 0.4 squared square root equal to mx double dot m v dv over dx. X double dot could be written as v dv over dx. X double dot means dv over dt. dv over dt could be written as v dv over dx. You know that. Okay, so now we can solve it. If you want, we can substitute the values here itself if you want. Mg 1.2 into 9.8 minus, here also I can substitute m 1.2, mass is given, no, we'll substitute it. Okay, now we have to solve it and integrate. You can see a lot of numbers are there. Anyway, when you solve this 1.2 into 9.81, that will become, that's a very simple number. Right, so, okay, that will become 11.76, 11.76. Okay, now look at here, this one. When you multiply 2 into 50, that is 100 divided by 0.5, so that is going to be 200, is it? Anyway, that's going to be 100 divided by 0.5 means into 2, so it's going to be 200. So 200 into 2, that is 400. Then I have to multiply this also. When I multiply inside, you can see first element, x squared plus square root of x squared plus 0.4 squared, x squared plus 0.4 squared will get cancelled. When you multiply this part, 2 into 50, 100 divided by 0.5, 200, 200 into 400, I'll write that one, 400 times x squared plus 0.4 squared, x squared plus 0.4 squared, it will get cancelled. When you multiply it, there will be x, 400x, is it? I'm right, no? Yeah. Then there is minus 0.5. So here when you multiply this inside, this 0.5, 0 will get cancelled. 2 into 50, which is 100, 100x. That is minus into minus plus 100x over 100x over 0.5, 0.5 get cancelled, minus 1, 100, yes, 100x over square root of x square plus 0.4 square will be there, equal to 1.2 v dv over dx. Okay, so we'll integrate it. Integral of 11.76 dx, limit from 0 x 0.3 to 0, minus 400 integral x dx 0.3 to 0, plus 100 integral of x dx over square root of x squared plus 0.4 squared 0.3 to 0 equal integral of 1.2 integral of v dv 0 to v. We need to find this v, all known, only that v is unknown. We are going to find that v. Okay, so I erased everything other than the last line. Integration now. This is easy. This integration easy. This is easy. But only this pattern you have to identify. You know, differentiation is easier. You can differentiate mostly any function. Generally, you can. It's very easy to differentiate. But integration is not easy. You have to identify the proper pattern of to integrate a function. So that means you have to identify proper pattern, otherwise you can't integrate any just function, is it? So here you can see the standard, this is a standard format we use. Normally, you know, if you differentiate this one, you will get inner part inside the square. If you differentiate, you will get 2x, but there's a square root is there, so half of the 2x is x. For example, you can remember this pattern. So if there's an integration something like this, square root of ax squared plus 2bx plus c, here ax plus b dx. What could be the integration of it? Remember this way. Now if you differentiate the denominator, we differentiate and see the denominator, d over dx of square root of ax squared plus 2bx 2bx plus c. If you differentiate it, you will get half ax squared plus 2bx plus c to the power of minus half. Is it? If you differentiate inside, you will get into 2ax plus 2b. Okay, so half into 2ax will be ax, half into 2b will be b. To the power minus half, you will get ax squared plus 2bx plus c. Okay, that means if you differentiate this, you will get this. So that means, remember that if you have denominator square inside the square root, half of the functions are in the numerator, then the integration of this one will be equal to this one. Say for example, if you have a something like this way, generally you can think like this, something like if there's a question something like integration of 3x plus 4 divided by 6x squared plus 8x plus 5. If you have an integration something like this integration you can directly write that is equal to square root of 6x squared plus 8x, because this 8x could be written as 2 into 4x. 2 into 4x, that 2 into 4x, when you differentiate 4x, you will get 4 here. 6x squared, when you consider 6x squared, sorry, this is 6x, I think I made a mistake, that is here 6x square plus 8x, numerator 6x plus 4. So this integration you can directly write 6x square plus 8x plus 5. It's a standard rule, because when you differentiate this one, you will get this one. Same way. So if you differentiate this one, you will get this one. So you can see the pattern. So here if we compare this pattern, ax squared, a is 1, b is not there, c is 0.4. So the integration of this one is going to be just square root of x squared plus 0.4 all things square. That is the integration of it. So the standard pattern, one of the pattern of integration, this one. So other way, this is true. So if I say integral of ax plus b over square root of ax squared plus 2bx plus c is equal to square root of ax squared plus 2bx, ax squared plus 2bx plus c. Because if you differentiate it, you will get this pattern. So 2bx, sorry. Or you can integrate by using integral udv format. That way also you can integrate. Okay, anyway, so we'll integrate this one. So if you integrate this one, 11.76 x, the limit from 0.3 to 0, minus 400 x squared by 2, limit from 0.3 to 0, plus 100. So I already explained the integration. So it's going to be 100 square root of x squared plus 0.4 squared, the limit from 0.3 to 0, equal 1.2 v squared by 2. Okay, so substitute. So this you will get 11.760. If you substitute, it will become 0. So 11.76 into 0.3. So that will be so that will be minus, because if you substitute 0, it will become 0. So 11.76 into 0.3 minus 400. X squared, if you put 0, it will become 0. So minus 0.3 squared by 2. This is minus, it will become plus 100. When you substitute 0 here, it will become 0.4, square root of 0.4 squared. Yes, square root of 0.4 squared. So that will be 0.4. Is it? Square root of, now when you substitute 0 here, x becomes 0, square root there. So 0 plus 0.4 square of square root, so 0.4 minus square root of 0.3 squared plus 0.4 squared, that's going to be 0.5 squared, equal to 0.6 v squared. Now everything we know, substitute and find the v, solve it and find the v, you will get the same early answer. Okay, you are using calculate all our numbers, careful, minus, here minus, plus, everything. Finally, you will get the same answer, 2.73 meter per second. Exactly the same answer, but only thing working much more in this question. Okay, so this is question number 7 and this diagram is given there. A particle P of mass M is attached to one end of a light rod of length L. So light rod, because if the rod has mass and when the rod rotates about one point, we need to consider moment of inertia. So to avoid it, they say it's a light rod. So that problem won't come here. It's not in your syllabus here. Anyway, so it's a light rod of length L. The other end of the rod is attached to a fixed point O. The rod can rotate freely in vertical plane about O. The particle is projected with speed u from point A. The line OA makes an angle alpha with the upward vertical. So this OA makes angle alpha with the vertical line, and alpha is less than 90 degree. When OP makes an angle theta with the upward vertical through O, the speed of P is V as shown in figure. Show that V squared equal U squared. That funny thing we had to show. So it's not an issue. We can use just speed means in circular motion, mostly vertical circular motion, relationship between initial speed and final speed, or relationship between speed at two different positions. We use law of conservation of energy. So here the particle, when it moves from this position A to this position, we can name it B. When it moves from A to B, we need to consider energy equation. What's happening? The speed will decrease. You know, when a particle is projected, when it moves upward direction on a vertical circular path, the speed will decrease, so kinetic energy will be lost, but the height is increasing, so gravitational potential energy will increase, or gravitational potential will be gained. So we need to find the vertical height moved by the particle when it moves from point A to point B. For that, we know the length of the light rod, which is L. So we need to find this height. So I'll draw it like this. When it is at point D, this is the height. It has gone up above O, that is H2. When it is at point A, its position is this one. This is H1. Okay, so the vertical height change when it moves from A to B, the change in vertical height when it moves from A to B is this much. That is H2 minus H1. H2 means we can consider this right angle triangle. In this right angle triangle, H2 is equal to L cos theta. In this right angle triangle, can you imagine this right angle triangle? H1 equal L, this is L cos alpha. So H, the vertical height moved by the particle when it moves from A to B, is L cos theta minus L cos alpha. That is the H, the vertical displacement of the particle. So this is the vertical displacement when it moves from here to here. This is the vertical displacement H. So H equal L cos theta minus L cos alpha is the vertical displacement. So we can say the energy equation for the motion from A to B, I am considering A to B. So loss in kinetic energy equal gain in GP, gravitational potential energy. So loss in kinetic energy, half mu squared, initial minus final is the loss. Half mv squared equal to gain in GP mg h. H means this one. L, I can take L out, cos theta minus cos alpha. Okay, so we need to make the V squared subject. So make the V subject. You can divide the whole equation by M, multiply by 2. So it will become U squared minus V squared equal to GL cos theta minus cos alpha. Okay, make the V squared subject. So V squared is equal to this A part, is it? That's actually A part, question number 7. So V squared is equal to U squared minus 2GL cos theta minus cos alpha. Okay, so that's the first part. So given that cos alpha equal 2 by 5 and u equals square root of 3GL, so that's given, they are saying. Show that P moves in a complete vertical circle. So actually here in a rod, when it moves, a particle attached to a rod means here the rod can't bend. So the only possible motion of the particle is circular motion. It can't have a projectile motion. But if it is a string, there's a possibility. Say for example, when a string is held vertically, like inextensible string, and if you project this particle at a particular speed u, depending on the speed of the u, or speed u, the particle can complete vertical circular motion, or when the particle reaches a particular height or particular position, it can go on a projectile depending on the u. So there are different conditions are there for the initial speed u that decides the different possibilities of motion. I'll discuss a separate lesson on that if I have time. But since it's a rod, the rod can't bend, so the particle has no chance of following a projectile motion. So we don't need to think about anything about the centripetal force here. Only thing we need to consider when the particle reaches the highest point. We'll name that highest point C. When the particle reaches the highest point, will it have a speed greater than 0? If the particle has a speed greater than 0 at the highest point C, that's enough. From that we can decide whether the particle can follow a complete circular motion. So we'll find the general equation. We got it. V square equal u square plus 2gl cos theta. And cos alpha is given, the initial speed is given. So we'll find B part. We'll find what could be the minimum speed v. So we'll rearrange this one. V squared equal u squared means square root of 3gl. It's given. All things squared. Square root of 3gl. All things squared. That is u squared minus 2gl cos theta plus 2gl cos alpha is given 2 by 5. Solve this one. That is square root of 3gl all things squared is 3gl plus 4gl over 5 minus 2gl cos theta. That is 15 plus 4, 19 gl over 5 minus 2gl cos theta. Okay, so that's the general equation for the square of the speed. So the minimum speed, the v is going to change depending on the angle theta, is it? GL, they all are constant. So the minimum value of v occurs when this portion which is subtracted from this one becomes the maximum. That means when cos theta becomes plus 1, cos theta is the maximum value of cos theta is plus 1. When cos theta becomes plus 1, you will subtract the larger quantity from this one. That will give the minimum value. Cos theta becomes plus 1 means theta equals 0. Theta equals 0 means at the highest point. So we can say V minimum occurs when cos theta equal 1, that is theta equals 0 at the highest point. So V minimum, we'll find it. How much is it? V minimum, that is at the highest point, 19 GL over 5 minus 2 GL, that is cos theta 1. So it's going to be 9 GL over 5, which is greater than 0. So since the minimum speed at the highest point is greater than 0 means it never becomes 0 at any points. It will continue a circular motion. That's the answer you should give. Since the minimum speed at the highest point is greater than 0, it has a real value. That means the motion of the particle never come to 0 at any point. It will continue circular motion. Here we don't need to think about the tension because the particle has only one possible path, circular path, because the rod is a rigid one. But if it is a string, we have to think about the tension. Yeah, I'll do a lesson later separately. So this is V square minimum. So V minimum equal this V square minimum. So V minimum, I have to take V minimum. Okay, V minimum, not V square. V minimum equal, take the square root of it, that is 3 square root of GL over 5, which is greater than 0. This is greater than 0. Therefore, it will continue cycle. Even at the highest point, the lowest speed is greater than 0. So it never comes to 0. V square, don't use it. Find the V minimum, not square. You have to take the square root of it. Then analyze, it's greater than 0. So even at the highest point, the speed won't be 0. I mean, it will continue the circular motion. Okay, so the last part of the last question, part C. As the rod rotates, the least tension in the rod is capital T and the greatest tension is KT. Find the exact value of K. So we need to get an expression for the tension T. Okay, so we will find the possible tension of the particle at position P. So that is C part. C part, is it? Yeah, part C. Yeah. So if you think about the forces acting on the particle, the weight is acting down. The tension, the particle has the intention of moving away from the center. So the rod will pull the particle towards it. So there will be tension. So particle will be pulled towards the center because the particle has intention of moving away due to centrifugal effect. Particle will stretch the rod. So there will be tension on the rod. Rod will exert the Newton's third law pair of force towards this direction. So this angle is equal to theta. This is simply this angle theta. This is theta. So here at this position, generally we will take theta. So the centripetal force means resultant force towards the center of the circular path is the centripetal force. So that is T plus mg cos theta equal mv squared over L. Okay, we know v squared equal u squared plus 2gl cos theta plus cos alpha. We know cos alpha equal 2 by 5, it's given. We got an expression earlier in part B. We got an expression earlier by substituting cos alpha 2 by 5. We got v squared equal, we got this equation, see that v squared equal u squared, yeah, we got yes, 2gl cos theta, yeah. U square also given square root of 3gl. So here we had to substitute for u square square root of 3gl. I don't need to do it again, I'll do it if you want. So v square equal, using this one, u square square root of 3gl all this squared minus 2gl. We already did this, 2gl cos theta minus cos alpha 2 by 5. Solve it and get expression for v squared. You will get v squared equal 19gl. We got this equation 19gl over 5 minus 2gl cos theta. We got this equation. So I am going to substitute this form here. So I am raised this and I am going to substitute. Already we did it, so I don't want to keep that one here. So I will substitute this expression for v squared there. So it will become T plus mg cos theta equal m over L. So v square we are going to substitute 19 gl over 5 minus 2gl cos theta. Okay, make the t subject. T is equal to multiply inside, so it will become 19 mg over 5. Is it 19 mg over 5? 19 mg over 5. When you multiply this by this, LL will get cancelled. Minus 2 mg cos theta. When it goes to the right, it will become minus, so 3 mg, minus 3 mg cos theta. Okay, so that's the final expression for the tension in terms of theta. So you know that maximum T occurs. To have maximum T, cos theta should become minus 1. You know that cos theta, the range is from minus 1 to plus 1. So when the cos theta becomes minus 1, minus 3 mg into minus, it will become plus. Is it? When cos theta equal minus 1, this will become plus. So the maximum T will be 19 mg over 5 plus 3 mg. But they are saying the maximum tension is KT. So they are saying, so T maximum occurs, T max equal KT, they are telling it. That is equal to 19 mg over 5 minus 3 mg cos theta minus 1. Where will it occur? Cos theta minus 1 means theta 180 degree, that is pi. Theta 180 degree means that happens at the lowest point. So the T maximum occurs at the lowest point when the theta becomes pi radians or 180 degree. For that, cos theta equal minus 1. Anyway, they are not asking the position. So we'll say Kt is equal to solid 19 mg over 5 plus 3 mg. So that is 15. 15 plus 19, that is 34 mg over 5, that is Kt. That is the equation 1. T minimum occurs. So from this equation again, T minimum occurs. They are saying that is T minimum is T. That occurs when cos theta equal to 1. Cos theta equal to 1, it will become minus 3 mg. So cos theta equal to 1 means when theta equal to 0, that occurs at the highest point. So T minimum equal to T, that is equal to 19 mg over 5 minus 3 mg into cos theta plus 1, that is when theta equals 0, that is theta equals 0 means highest point. So that is going to be how much? 19 mg over 5 minus 15 mg, 4 mg over 5, that is the minimum, which is T. Okay, so we have two equations that relates maximum and minimum tensions. Now we can continue. So for that we can divide equation 1 by equation 2. I'll erase this. Okay, so equation 1 divided by equation 2, 1 over 2. That's going to be Kt over T equal to 34 mg over 5 into, when you divide it becomes upside down, is it? You know level math. 5 over 4 mg. So mg will get cancelled, 5 will get cancelled, 34 over 4. So tt will get cancelled. So k is going to be 34 over 4. So 34 over 4 means it will be 8.5. That's the value of k. 8.5. Okay, so that's all this January 2022 paper. I hope you understood. You can pass your comments. Okay, we'll meet during another discussion. Bye.